If a function has an inverse function, the inverse function undoes or reverses the process of the original function. Let's first look at some diagrams that represent this idea, and then we will get some practice writing formulas for function inverses. Suppose x and y vary together, such that y is a function of x. We'll say that the name of this function is f, so that f of x is equal to y. If x is also a function of y, then f has a function inverse, and so we can write f inverse of y is equal to x. There are many ways to think about and visualize this idea. Here are just a couple. So let's imagine we have all of the values of x over here, and we've got the values of y over here. If we look at any specific value of x, so maybe we'll represent a value of x right here, but we could have picked any one. If we take that value and we input it into f, f will give us an output that's a value of y. Now if we take that value of y, we input it into f inverse will give us an output of the original value of x. So if we input x into f, we end up with the value of y. If we input that value of y into f inverse undoes the process and gives us back the original value of x. Here's one more way we might think about this. Let's think about f as some kind of function machine. So we know f takes an input x, so if we give an input of x to the function f, it's going to output a value of y. And similarly, we can imagine f inverse. So f inverse takes a value of y as its input, so we input y into f inverse, and it outputs a value of x. So I'll change my color here. Let's imagine chaining together this process. So we'll give f a value of x, so we input x in. F gives us a value of y as an output. If we take that value of y and input it into f inverse is going to output the original value of x. So you can see just from the diagram we have this very circular looking thing. That's because f and f inverse reverse the process of the other function. Let's use this idea in the context of a function formula. So suppose f of x is equal to 3x minus 5, where f of x is equal to y. And the function process for f looks like the following. So f takes a value of x. So if we give x an input, or we give f an input of x, it takes that value of x and it multiplies by 3. So that's right here. Then once we do that, we subtract 5. So the next step, we subtract 5. And once we do that, we get a value of y. The function f inverse is going to reverse this process. So what it's going to do is take a value of y. So take a value of y. And then going backwards, instead of subtracting 5, we have to add 5. Then next, instead of multiplying by 3, we have to undo that, and that's dividing by 3. So we divide by 3, and after we do that, we get the corresponding value of x. So this function inverse just undoes the process of f. If we think about this, we can actually write a function formula for f inverse. So f inverse takes an input of y. So we'll start with the value of y, and then we add 5 to it. So we take a value of y, we add 5 to it. Then next, we have to divide by 3. And once we do that, we get our output of x. Therefore, f inverse of y is equal to y plus 5 divided by 3. And this is the function rule or function formula for f inverse. So notice that we could also solve this a different way. We could write a formula for f inverse in a slightly different way. So f of x is equal to 3x minus 5, and f of x is equal to y. So if we scroll down a little bit, we see that y is equal to 3x, what did I say, minus 5? 3x minus 5. If we solve this for x, we do a little algebra and we solve for x, we get x is equal to y plus 5 divided by 3. But we know that f inverse of y should give us the value of x. And we know from our formula that x is equal to y plus 5 divided by 3. So our function formula for f inverse could solve for algebraically like this.